Okay, so this first one on the quiz, you have to describe the function, and you'll notice it has to do with wholes. So the first thing we have to do for a whole is we have to factor. So this top part, remember, that's difference of squares. So if it's of the form a squared plus b squared, it factors into a plus b and a minus b. So our top factors into x minus 3 and x plus 3. Now the bottom is that box and circle. So we have x squared, 8x, and 15. And so a times c goes on top, so 1 times 15 is 15. B goes on the bottom is 8. So what multiplies to 15 and adds to 8 is 5 and 3. So 5x and 3x. So on the outside we have x and x plus 5 and plus 3. So this factors into x plus 5 and x plus 3. All right, so there's a whole. That term reduces out. So where does x plus 3 equal 0? Is at x equals negative 3. So our whole is at negative 3. Now the second one here, which of the following statements are true? Well, if we look at this one, it definitely has a slant asymptote. So I'm going to cross out the horizontal, because it does not have a horizontal at negative 5. We don't know anything about that, about the degree, but if you remember to find our asymptotes, we look at the degree. And again, this was for a horizontal and slant. If our numerator degree is less than the denominator, it's automatically at y equals 0. So like if you had x minus 1 over x squared plus 5x plus 2, it's at the degrees, the top is less. If our degrees are equal, so for example, if it was 2x squared plus 5 over 4x squared plus 6, then it's at our leading coefficients of 2 over 4. And if our numerator is greater than the denominator by 1, there is a slant asymptote, and you have to do long division. So this one, the numerator degree is 1 more than the denominator. Now for the possible equations, there's a lot of things that go into this one. So I'm going to make a fraction key. So I know that there's a whole at 4. So I know if there's a whole at 4, there has to be x minus 4 and x minus 4 on the top and bottom, because that term reduces out that there's a whole. If I look at this graph, there's a vertical at negative 2. So that means x plus 2 has to be on the bottom, because that gives us our vertical asymptote. I know it crosses at negative 5. So I know x plus 5 has to be on the top, because that is our x-intercept. And then I know that there's a horizontal here at 2. So I know that our degree has to be the same, and it is. There's 2 x's. So our leading coefficients would have to be 2 over 1, or you could just have a 2 there. And now we could double check a lot of things. We could double check our whole and say, well, if I plug in a value of 4, do I get a y value of 3? But I'm all right if you have identified all of these things. Your whole, x-intercept, vertical, and horizontal. So the next one here. What is happening is our limit. So this is the limit as we go to 5, because we know it's undefined there, from the left-hand side. So if I move to 5, 4.9, 4.99, 4.999, what is happening to those values? Well, they're getting more negative, so it's going down to negative infinity. Now the other one says as I go to the right-hand side. So as I go to 5, 5.1, 5.01, as I get closer, those numbers are getting bigger, so it's going to positive infinity. So does it have a whole or vertical asymptote? Well, I know something happens at 5. And as I know as it goes to 5 from the left, the graph shoots down. As it goes from the right, the graph is shooting up. Well, that means there has to be a vertical asymptote, because 1 gets bigger, So it gets bigger and one gets smaller. And you could explain that in your own words. Now, some people ask, what does it mean if there's a hole? Well, let's say I had g of x. And g of x went 2.5, 2.59, 2.599. And if I went from the other side, maybe it was 2.65, 2.63, 2.61. Well, if you notice, as I move closer, it's not getting bigger. It's getting bigger, but not like up before. And it's getting smaller, but not like that. That these numbers are relatively close. So if you were to make an estimate, what number would go here? I'd say 599, 2.61, 2.6. So if it goes towards a number, that means there's a hole. Now, number 5, we have to find the slant asymptote. So if we look at our degrees, the numerator is greater than the denominator by 1, so there's a slant. So we have to do long division. And so if you remember our long division, the top divided by the bottom. And so we did division with these boxes. So the outside of our box, x squared plus 2x minus 9. And then on the inside, so the first thing we put on this inside is that x cubed. So I'm going to put that x cubed here. So x squared times what gives you x cubed is x. Now if I fill in the puzzle, this is negative 2x squared, negative 9x. So now the next thing I need on the inside is 8x squareds. Well, I have 2x squareds here. So what would this other one be to add up to 8x squared? Well, that's 6x squared. So I know up here is going to be plus 6. So that would be 12x, negative 54x. Oh, negative 54, excuse me. And so in this last column, I can look and I can say, okay, well, there's no x's. So if I add these x's, I have 3x. But if I look, there's no just x terms on the inside. So to negate that 3x, this would have to be negative 3x. And then number-wise, there's a negative 5. Well, I have negative 54. So what would go there to add up to negative 5 would be 49. Now, I can't turn x squared into this, so that's our remainder. And our equation for the slant is just what's right on top here of x plus 6. All right, the next one here. Here's a graph of a rational function, and there's asymptotes we have at 2 here, at 8, and at 1. So it asks the question, when is it less than 0? Well, here is 0. So when is it less than 0? Well, that's right here, and right here is when it's under 0. So how do I describe that? We describe with our x values. So from x equals 2 to 4. And it can equal 0, so I'm going to put a bracket. And then it starts up again at 7 to 8. Now the next part is asking, when is it greater than 1? So here is the line of 1. When is it above 1? Well, here it's above 1, and here it's above 1. So how do we describe that part? Well, from our x values, from negative infinity to 2, and it'll be a parenthesis because it doesn't quite reach 1. It just asks up to 1. And then again from 8 to infinity. All right, this next one are talking about limits. So as we go to 5, so we see 5 is this asymptote. So this says 5 from the left side. So as I go to 5 from the left side, what's happening to our graph? Well, it's going to negative infinity. I need to make this smaller. There we go. And as I go to 5 from the right-hand side, so as I go to that asymptote, it's shooting up. So it's positive infinity. And now the next one is saying a limit as we go to 6. Well, at 6, there's a hole right there. So as we go to that hole from the left-hand side and the right-hand side, it's not shooting up or down, it's going to that point, and that point has a height of 3. So it's moving towards that height of 3. Where our other ones are getting bigger and smaller, that hole goes to that height. All right, so this next one, I'm going to do the factoring here. I'm not going to make the box in circles. So this one factors into x minus 5 and x plus 3. And then this bottom one, we can leave the 2 on the outside, and it factors into x minus 5 and x plus 1. So if we look at this, it reduces out, so there's a hole. So x plus 3 over 2 times x plus 1 is our simplified form. So it says find the zeros, so the x-intercepts. So that we look in our numerator, because where is that function equal to 0? Well, at x equals negative 3. Find the y-intercept. To find that, well, that's where plug in 0 for x's. So 0 plus 3 over 2 times 0 plus 1. Oh, sorry, this should factor into 2, my bad. X plus 2. So this is 2 over 2, which is 1. Vertical asymptotes, that's where we look in our denominator. So where is that makes a 0 in our denominator is when x equals negative 1. We'll write this limit function at the end. So our holes, x minus 5 reduced out, so there's a hole at 5. And then if we plug that in for our x value, so what's 5 plus 2 over 2 times 5 plus 1? So that's 7, 2 times 6 is 12. So there's the coordinate of our hole. We'll come back to that one. In our horizontal, when we look at our original, our degrees are the same. So what's that coefficient? Is 1/2. So if I was to graph this, horizontal at 1/2, a vertical at negative 1. What else do we know? The y-intercept is 1. Our x-intercept, the zeros are at negative 3. And there's a hole at the point 5, 2, 3, 4, 5, and 7, 12. So a little bit above that. So we know our swoops, it must swoop, whoops, there and here. So when it goes back to this limit notation at our hole, the limit is f of x as it goes to our hole of 5 from the right-hand side, and the limit of f of x as it goes to our hole from the left-hand side. Well, as it goes to that hole, it's going to that height of 7/12. And then our vertical asymptote. So the limit of f of x as x goes to our vertical asymptote of negative 1. And the limit of f of x as x goes to our vertical asymptote from the positive side. So as it goes from the right, so again, as I go on, or the left-hand side, it's going down. So that means our right-hand side, it's going up.